Good morning. So in the last class, we have discussed about the Bode plot and how the stability of the system can be studied by using the Bode plot. And in this class, we discuss how to construct a Bode plot. And in the previous classes, we have discussed about the how the Bode plot initially, what are the factors are there, and each factor, what is its contribution to the magnitude plot and as well as phase angle plot. Based on that, we are going to plot the Bode plot. So Bode plot, we know that it consists of two plots, that is magnitude plot and as well as phase angle plot. So in order to find the magnitude for the each factor, first and foremost thing which you need to do is making the g of s, that is open loop transfer function, in the time constant form. So look at that time constant form is there or not. So it is not there. Time constant form is nothing but 1 plus ts form. 1 plus ts form. So first write down the g of s into h of s is equal to 800 into s plus 2 divided by s square into s plus 10 into s plus 40. So then we need to write this in the time constant form. So in the sense, what we say is we need to write the, take out the constant term outside so that it will become 1 plus ts form. So I can write 800 into, take out the 2 common, 1 minute. Yeah. Yeah. So here yeah. So here I'll write down 800, 2 taken common out. So 1 plus s by 2, 1 plus s by 2. One plus s by 2 divided by s square into 10. I can take out common, 1 plus s by 10. Then 40 I can take out common, so 1 plus s by 40. So from this, so we can cancel out this system gain term. 0 0 will be cancelled out, and 4 1s are 4 2s are. So totally I'm going to get 4 into 1 plus s by 2 divided by s square into 1 plus s by 10 into 1 plus s by 40. So initial Bode plot is depends on these two things. One is system gain k, and as well as poles are 0 set origin. So here there are no 0 set origin. So I'll take it as pole set origin s square, 2 poles at origin, right? So now once you write the time constant form, then we need to check what are the factors are present in this that we need to write down first. So if you look at this, there are 4 factors, right? So first write down the factors. First write down the factors present in the system. What are the factors present? So if you look at this, first one is system gain K. That is what we can say, system gain K. So here, what is the K value? K is equal to 4 here. So K is equal to 4. So we need to draw the 20 log K line in the magnitude while drawing the magnitude plot. So first we'll find out what are the factors are present in the system, right? So second one is poles, 2 poles at origin. There are 2 poles at origin. S square means there are 2 poles at origin. S square equal to 0 means S1 equal to 0 and S2 equal to 0. So 2 poles at origin, right? So then third one. So third one is what are the poles we have here? Here we look at the based on the what you call corner frequency. Based on the corner frequency. We need to write what are the see here. If you look at 1 plus Ts form, omega c equal to what is the corner frequency for the poles? So omega c is equal to 1 by T. 1 by T. So if you look at the simple 0, we have the simple 0 here. So if you look at here, this is the simple 0 and this is the simple pole and this is also a simple pole. So among these 3, see which one comes first, means the omega value starts from 0.12 and then it will goes up 10,000, 10 to the power of 5, like that it will goes off. So it means that, see in the order, so 0.1, then 1, 10. So which comes first? Omega c, see if you take 1 by T, so 1 by 10, 1 by 1 by 10 is 10, 1 by 1 by 40 is 40, 1 by 1 by 2 is equal to 2. So here the 2 radians per second is comes first, then because in the order, if you go in this direction, 2 radians will come first, then 10 radians will come first, then 40 radians will come first. So this will become as omega c1, omega c2, omega c3. Likewise, we need to find the sequence of omega c1, omega c2, omega c3. So which one is omega c1 here? If you look at the simple 0. So simple 0 you need to write down here, simple 0. Then the fourth one is simple pole 1 and simple pole 2. Say for example, this is simple pole 1 and then simple pole 2. So simple pole 1. Then fifth one is simple pole 2. Simple pole 2. We can write the 1 plus S by 10. 1 plus S by 10. Here is 1 plus S by 40. And this is 1 plus S by 2. So now we need to write the contributions of these. So we know corner frequency. We have found out that omega c1 is equal to 1 by T, 1 by 1 by T, that is 1 by 2. So that is 2 radians per second. And omega c2 here is 1 by 10, which is equal to 10 radians per second. Then omega c3 is equal to 1 by 1 by 40, which is equal to 40 radians per second. 40 radians per second. So here, if you look at the corner frequencies by simple 0 is starting first, means the magnitude plot. If you draw, then the contribution of each factors is in the order. It is in this order. So these two will be taken. That is system gain K and 2 poles at origin will be taken first, because this gives the initial Bode plot. So initial Bode plot will be drawn. Initial Bode plot will be drawn based on these two. One is system gain K. The other one is 2 poles at origin. So first we consider these two. And then we'll go plotting the magnitude plot. We'll go for plotting the magnitude plot. Right? So magnitude plot. So first we'll do calculations and then we'll go for plotting a graph. So for calculations, yeah. So what is the first one is we discussed, that is k. That is for k is equal to 4. The magnitude we know that the magnitude is equal to 20 log k. So that is nothing but 20 log 4 base 10. So find out the log 4 base 10 value, how much it is going to be, and multiply it by 12. So 20, you are going to get 12 dB. Right. So this is the first thing, means 20 log k line we know. Then the second one is 2 poles at origin. So we have given that 2 poles at origin, and the 2 poles are at origin. So we know that the slope contributions, because it forms as a line. So line of slope contribution is going to be 1 pole at origin is minus 20 dB, and 2 poles at origin it will be minus 40 dB. So 2 poles at origin contributes a slope of minus 40 dB per decade. So because nothing but it is minus 20 into p. So here the p is equal to 2. So minus 20 into 2, which will give minus 40 dB per decade. So this is the slope contributions by the poles at origin. So in the initial Bode plot, we'll draw these two factors by considering. So by considering these two factors. See here, the initial Bode plot is drawn based on like this. So this is, I'll be taking as 20 log k line. This is 0 dB line. And here this 20 dB, I'll be taking as 12 will become here. So then 40, then 60, like that it will be there, then minus 20 will be there, right? So now the 20 log k line is going to be, this is 12 dB line, say 12 dB line. So I'll be drawing 20 log k line. This is the 20 log k line. And there are how many poles at origin? So there are 2 poles at origin. So I'll be drawing 2 poles at origin, means with the decreasing slope with a minus 40 dB. Minus 40 dB means this is going to be 0.1, and omega is equal to 1 here. So both intersect the 0 dB line at this point. So you need to draw this 40 dB line. This is a minus 40 dB line which I have mentioned here. This starts from 40 and then stop at this point. So this is the intersection point at omega is equal to 1 and 0 dB line. This is the point of intersection which has to be shifted onto the 20 log k line. That is, we are going to shift this point onto this 20 log k line like this. Means the same point, say for example this is A point is shifted to here. The A is nothing but intersection of this line of slope, and as well as 0 dB line. The line of slope of 40 and 0 dB line, that is what omega equal to 1 So this point is shifted to this position, that is onto the 20 log k line. This is 20 log k is equal to 12 dB line. So 12 dB line we are going to shift. This is a very important part in sketching the Bode plot. Okay. So after shifting this point onto this, then through this point we need to draw a parallel line passing through the same point and parallel to this 40 line of slope minus 40. It means that if I draw a parallel line which is exactly passing through this point, and then this will be passing through this point we need to draw. So once you draw this, then immediately we need to go for the next factor, which is up to here. We cannot stop. We have to continue this line, till where? Continue to the next corner frequency. To continue to this line, next corner frequency means at omega is equal to 2 radians per second. So this is the 2 radians per second line. So until this line touches, we need to extend this line. We need to extend this line in the same slope, with the same slope. Means this is the resultant. This is the resultant of K and poles at origin. This is the first and foremost thing which you need to draw in the Bode plot, that is while drawing the magnitude plot. So we need to consider these two factors, and then we have to starting with the initial construction of initial Bode plot. Construction of initial Bode plot is nothing but it is the procedure. So first find out the 20 lakh K line value. It gives the 12 dB line. So that 12 dB, so 0 to 20, there are 5 divisions. Each division is 4. So third division, it will give the 12 dB. So at 12 dB line, we are going to draw a line parallel to the log omega line. So that is 20 lakh line. And we need to find out the intersection of point, that is omega equal to 1 and 0 dB line. From that, you need to shift the point onto the 20 lakh line. So here, this 40, why I have started from 40 in the sense, because it is given as minus 40 dB per decade. So it is because there are 2 poles at origin, it starts from 40. 3 poles at origin, it starts from 60. 1 pole at origin, it starts from 20. So this point, the point of intersection has to be shifted onto this, and we need to draw a parallel line. This is the parallel line which you have drawn, passing through this point, which is the point here. This is the intersection point of 20 lakh. We have shifted this A point onto the 20 lakh line. We have shifted this point onto the 20 lakh line, and through this point we have we need to draw a parallel line to this minus 40 dB slope line. So to which line we have to draw parallel means to the number of poles at origin line. Which is the number of poles at origin line? There are 2 poles at origin. So this is the line of slope which represents the 2 poles at origin. Then we'll go to this one, and then where we are going to find out the resultant of the K and as well as poles at origin. So this is the line of slope. Which will be continued till the next corner frequency. Where is the next corner frequency comes? So here we have discussed in the beginning. So corner frequencies we have discussed. So where is the next corner frequency comes? At 2 radians per second. So at 2 radians per second, what you are going to get here? One simple 0. So third one is simple 0. Simple 0 is going to come into the picture. Simple 0 is coming to the picture at omega C1 is equal to 2 radians per second. So what is the simple 0 slope contribution is? It contributes plus 20 dB per decade, and the resultant slope, when you find out, this is the previous line having this is the minus 40 dB line. This is a minus 40 dB per decade. So previous line slope is minus 40 dB, and current this is going to be plus 20 dB. So the resultant will be minus 20 dB. So this minus 40 dB is the previous one. Previous factor is what? This factor. This is the factor which contributes minus 40 dB. And this factor, so when it comes to calculation of this factor, combiningly we need to add the resultant of slopes. Add the slopes, that is minus 40 plus 20 dB. Why plus 20 dB? Because it is a simple 0. 0 contributes plus 20 dB per decade. Whereas the poles contributes negative slopes and zeros contributes the positive slopes. So minus 40 dB plus 20 dB, which is equal to minus 20 dB per decade. So this is the resultant. This is the resultant after adding. So minus 20 dB is nothing but it is a line of slope which comes 20 and A. When you join 20 and A, see here, when you join 20 and A, this is the line of slope which has the minus 20 dB. So in order to draw from the 2 radians per second, we need to draw parallel to this line, means parallel to this line. So you extend this line to find out which is the minus 20 dB, and then from this point, we need to draw parallel to this. Means here the line of slope is going to be here. It is parallel to this dotted line. This dotted line represents minus 20 dB. So here the resultant is going to be minus 40 plus 20. It is equal to minus 20 dB per decade. So this is the line of slope which is represents the minus 20 dB per decade. So this line has to be continued till where? It has to be continued till the next corner frequency. When is the next corner frequency? That is 10 radians per second. So this is the point where at the 10 radians per second is there. So up to this point, that is means up to this point it has to be continued. Now at this 10 radians per second, what will happen? So fourth one is simple pole which is 1 plus S by 10. The simple pole which has the omega C1 is equal to 10 radians per second is going to be contributes from this point, this factor is going to contribute to the magnitude plot. This factor is going to contribute from the omega C1 is equal to 10 radians per second. From omega C1 is equal to 10 radians per second. So it means that the previous one is going to be minus 20 dB because the resultant is going to be minus 20 dB. So minus 20 dB plus what is the simple pole contribution? It contributes minus 20 dB per decade. It contributes minus 20 dB per decade to the magnitude plot. So here, if you look at the plus minus 20 dB plus of minus 20 dB, so which you are going to algebraic addition. So minus 20 dB minus 20, so it will become minus 40 dB line. So once again, the resultant slope is going to be minus 40 dB per decade. So it means that the minus 40 dB line is here. So just I'm showing the dotted line to draw a parallel line to this. So once again, you need to draw a parallel line, which is minus 40 dB line. So this will be continued till where? It will be continued till 40 radians per second. Say this is 20 and 30 and this is 40. So up to this point, say this is 40 radians per second, we are going to extend this line. So the resultant of this is going to be minus 40. This is the minus 40 dB per decade. Similarly, the next at omega c equal to 40, at omega c is equal to fifth factor, which is simple pole 2, which is 1 plus s by 40, means at omega c1 is equal to 40 radians per second. Means from 40 radians per second, it is going to come into the picture. I mean, it is going to contribute to the magnitude plot. So at 40 radians per second, in the sense, this contribution, even though this is a simple pole, this contribution is minus 20 dB per decade. So what is the previous result? Resultant magnitude, that is slope of magnitude, is going to be minus 40 dB per decade. So that minus 40 dB per decade is the previous line resultant, that is minus 40 plus, then what is the simple pole contribution? Minus 20. So total is minus 40 minus 20, which is equal to minus 60 dB per decade. So then at omega c equal to 40 radians per second, at omega c equal to 40 radians per second, the slope, the resultant slope, is going to be added with the minus 20 dB for the previous one. So totally minus 60 dB line is going to be come into the picture. So here, if you draw that resultant, see this one from this point, The 60 dB line means I need to draw a line joining to this to omega equal to 1, and then so this line will be extended like this so that it will represent. So to this line we need to draw a parallel to that. So that line is nothing but 60 dB line. Say for example, this is the line which represents the minus 60 dB, minus 60 dB per decade. So this is how the magnitude plot is going to be drawn. So here first is, see, this is the which one I'm showing here is okay. So this complete thing from here to here. So from
Sir,
yes,
minus 60 line is extended till
next corner
x-axis.
frequency. Till next corner frequency is not there in the system, so it will be left like that. It will be left like that. Okay, there is no end for this. There is no end for this point because this will be extended till the next corner frequency comes. So because we have only up to omega C3, omega C4 is not there. Why? Because there is no simple pole or not a simple zero present in the system. So we can stop this magnitude line at any point. Means starting point is going to be this one. I can stop at any point here. Okay, from this point to just extend a little, and then stop, because there is no stopping point for this magnitude slope of line. Okay.
Yes, sir.
Yeah. So this is how we need to construct the Bode plot of magnitude plot of Bode plot, because this is only one plot we have constructed. So this is what we can say it is a magnitude plot. So how to construct the magnitude plot is first consider the poles which you have present in this system. That is, we have the different factors which you have. First we need to look into this time constant factor. Time constant, once you write down the time constant form, then what are the factors are present in the system that we need to write down. That is system gain K, that poles at origin. Then simple 0 we have to write first, or simple pole 1 we have to write first, or simple pole 2 we have to write first. That depends. This is the order. This is the order which you are maintaining. So why I have written simple 0 first? Because the omega C1 is 2. It is increasing order, right? So it should be in ascending order. That omega should be in ascending order. In the same order, these factors will be contributed in the magnitude plot. These factors will be contributed in the same order. That is, simple 0 is coming into the picture first, then simple pole 1, then simple pole 2. So likewise, we need to write accordingly with the corner frequencies. So omega C1 is 2 radians per second for this, and omega C2 is 10 radians per second for the simple pole 1, and omega C3 is 40 radians per second for simple pole 2. Likewise, once you have write down the factors, then we need to start with the magnitude plot. So first magnitude plot is always start with the initial construction of the Bode plot. So initial construction of the Bode plot in the sense which we can say the combining of system gain K and combining of the system gain K, our poles are zeros at origin. So in this problem we have S square. S square means poles at origin. So zeros at origin factor is not there in this case. So what we do is we can take the poles, 2 poles at origin. So combining these two. So these two factors to be combined. So once you once you look at these two factors, then that is for K is equal to 4. What is the magnitude of the K? That is 20 log K, that is 20 log K line. Then once you got the 20 log K value, that is 12 dB, then find out these 2 poles at origin. When the poles are there, that contribution of the slope is going to be minus 40 dB per decade. So once you got this minus 40 dB per decade, this is nothing but, see, the line of slope which starts from plus 40 in this magnitude plot. See, this is 40 is the starting point, and omega 1 line and 0 dB line is the ending point of that. So this is the line which represents the poles at origin, and 12 dB is the line which represents the 12 log K line. So now what I have to do is the shifting of this point A, which is shifted from the 0 dB line and omega equal to 1 line onto the 20 log K line, onto the 20 log K line. So we are shifted this point onto this 20 log K line. After shifting this point, then we need to draw a resultant line. Resultant line, which is how we are going to do. The resultant line is nothing but which is passing through the intersection point A and parallel to the line of slope, which is represented by the poles at origin. So poles at origin line of slope is minus 40 dB. So minus 40 dB line parallelly you need to draw one more line passing through the point of intersection A, that is A. So once you draw this line, you need to extend this line until where we need to extend, because it is till the next corner frequency. Next factor is going to come into the picture at what radians per second. So the next factor simple 0, which is coming at omega C1 is equal to 2 radians per second. So that point, till that point we need to extend. That's why you see omega C equal to 2 radians per second. I stopped at that point. Then at that point, that is simple 0 comes into the picture, which has the slope is going to be plus 20 dB per decade. The line of slope for this simple 0 is plus 20 dB per decade. So that's why we have drawn the slope of line adding to the previous line of slope, which is minus 40 dB. It is nothing but algebraical sum of all these slopes. It is nothing but algebraical sum of all the slopes. Why I am adding the slopes? Because each one represents a line equation. So line equations cannot be drawn for a different values of omega, that is 0 to infinity, varying the 0 to infinity. So just adding the slopes of the lines will give the resultant of a magnitude plot. So that is why the previous factor is having the minus 40 dB and current factor is having the plus 20 dB per decade. So minus 40 plus 20, it gives the minus 20 dB per decade. So once you understand this, then we can go to the next factor, that is simple pole, which is 1 plus s by 10. So then, see, this will be extended from the 2 radians per second till 10 radians per second. That line of slope will be continued. At omega c equal to 10 radians per second, we are going to stop this line, and then because the new factor is going to coming into the picture at omega c equal to 10. What is that new factor? That is simple pole. So what is the slope contribution by the simple pole is minus 20 dB per decade. What is the resultant of the previous one is minus 20. So minus 20 plus minus 20, it will become minus 40 is the resultant. From 10 radians per second, we need to draw a minus 40 dB per decade line. So that is why from 10 to till where we need to write, till the next corner frequency. Next corner frequency is going to be 40 radians per second, that is omega C3 is equal to 40 radians per second. So up to that point, we are going to extend this line. So now at omega c equal to 40 radians per second, simple pole will come into the picture with a slope of line of slope contribution is minus 20 dB per decade. And what is the previous resultant is minus 40 dB plus minus 20, which will give the minus 60 dB. So from that point, that is omega c equal to 40, omega c equal to 40 point, it has to give the minus 60 dB slope line. So how the minus 60 dB slope line looks like means, if you join this 0 dB line and omega equal to 1, that point A and 60 plus 60 where it is from the magnitude plot. So this point and then A point, if you join these two, then we are going to get this one. Okay, so that is how we can draw the magnitude plot. We can draw the magnitude plot using these factors. So next is, once you finish this magnitude plot construction, then the second plot is going to be, in this case, is phase angle plot. In this case is phase angle plot. Okay, so phase angle plot is to be drawn. Phase angle plot is to be drawn. Okay. So now you got this, how it can be drawn, this. Right. Now we'll go with the how to construct this phase angle plot. So up to this is a magnitude plot, then we have to go for phase angle plot. So phase angle plot, because it is a angle of 1 plus j, say for example x plus j omega. So we need to calculate. The x plus jy. So tan inverse of y by x. If it is a poles, the angle will be minus tan inverse y by x. If it is zeros, then angle will be plus tan inverse y by x. For the factor k, because we have discussed in the last class, for factor k, it is going to be zero contribution for factor k. And the poles at origin contributes minus 90 degrees, minus 90 degrees. So we can go with minus 90 degrees for the poles at origin, and simple pole which contributes based on the 1 plus j omega. So S is replaced by j omega in this case. S is replaced by j omega in this case, so that all the factors in this we are going to replace the S is going to be replaced by j omega. So here you write down, wait a minute. Okay, it was struck, so I was unable to explain. Okay. The Jungle plot anyhow we will discuss in the next class.